Now more results. Results are integral of 1 upon x square minus a square, where a is constant. Integral of 1 upon x square minus a square is 1 upon 2a log mod x minus a upon x plus a plus c. Integral of 1 upon x square minus a square with respect to x is 1 upon 2a log mod x minus a upon x plus a. Second formula, integral of 1 upon a square minus x square, that is 1 upon 2a log mod. Now say, here I have changed sign. On left hand side sign is changed, so this side sign will be changed, and including a minus sign inside log, this number will be reciprocal. So x plus a upon x minus a plus c. Because of modulus, you can change this order. Instead of x minus a, you can put here a minus x, here a plus x. Because of modulus, you can put here a minus x, a plus x. So remember difference. Compare both results and remember what is the difference in these results. Third result, 1 upon root x square plus a square. 1 upon root x square plus a square is log modulus x plus root x square plus a square plus c. 1 upon root x square minus a square. So it is log mod x plus root x square minus a square plus c. Now see, observe these two results. Here x square plus a square and this is x square minus a square. So difference in these two results is only inside radical sign. Here we keep x square plus a square and here x square minus x square. So log x plus everything same. Only difference is x square plus a square, put here x square plus a square, x square minus a square, put here x square minus a square. Then integral of 1 upon root a square minus x square. Integral of 1 upon root a square minus x square is sine inverse x upon a plus c. A square minus x square, sine inverse x upon c. We have a result already discussed previously. Integral of 1 upon root 1 minus x square. Integral of 1 upon root 1 minus x square. See, here pattern is same. In that result we had integral of 1 upon root 1 minus x square and integral was sine inverse x plus c. So here now same result in different form, root a square minus x square. Then integral of 1 upon x square plus a square. Previously we discussed one result. Integral of 1 upon x square plus 1. It was tan inverse x plus c. Here plus a square. So 1 upon a tan inverse x upon a plus c. So now we are adding these results in application. To understand this formula, here I am taking short questions. Suppose we want 1 upon x square minus 49. 1 upon x square minus 49. So if you observe and if you compare this with first result, so it can be matched with 1 upon x square minus a square. So look this as 1 upon x square minus 7 square. So its matching is with 1 upon x square minus a square. So it is equal to, by this formula, 1 upon 2a, this is our a, 1 upon x square minus a square, so 1 upon 2a log mod x minus a upon x plus a plus c. Second result, second example, application of second formula. Suppose 1 upon 5 minus x square. We want to integrate 1 upon 5 minus x square. So if you compare with this result, its pattern is like 1 upon a square minus x square. So 5 can be expressed as root 5 square minus x square. So now you can see ditto pattern, a square minus x square. So what is a? Root 5. So by second result, 1 upon 2a, this is a, 2a log mod x plus a upon x minus a plus c. Then third example, suppose 1 upon root x square plus 81, root x square plus 81. So you can match with this result, x square plus a square. This is a square, keep as it is. It is 9 square. Now by this formula, it is equal to log mod x plus root x square plus 9 square plus c. Example 4 on fourth statement. Integral of 1 upon root x square minus 2. So 1 upon root x square minus a square. So here a square is 2. So by this formula, it is equal to log mod x plus root x square minus a square is 2, keep as it is. Fifth result, 1 upon root 7 minus x square. 1 upon root 7 minus x square. Now say, this is a square and here it is a. So look this as 1 upon root 7 square minus x square. So you can compare with that result 5. 1 upon root a square minus x square is sine inverse x upon a plus c. Sixth result, integral of 1 upon x square plus 25. So it is like 1 upon x square plus 5 square. That is, now by this formula, 1 upon x square plus a square, x square plus a square. So it is 1 upon a tan inverse x upon a plus c. So on these 5 results, these are simple 6 applications. Integral of 3x square upon x raised to 6 plus 1. Say, look here, denominator is x raised to 6 plus 1 and in any result in any formula, we don't have access to 6. In every result, whatever we have list of formulas, just we discussed, 1 upon x square plus a square, 1 upon x square minus a square. So in the list of formula, in denominator we have x square, and here it is x raised to 6. So to see here x square, if we take x cube equal to t, we take x cube equal to t, then this can be converted in t square plus 1. So we can do something. So taking x cube equal to t, now so 3x square dx is dt. So taking this substitute, this 3x square, it will be removed with dx. So integral is, here x cube is t, so x raised to 6 is t square plus 1, and 3x square dx is dt. So this is like 1 upon x square plus 1. 1 upon t square plus 1 with respect to t. So integrating this by formula, its integral is tan inverse t. Now value of t is x cube. So tan inverse x cube plus c. Now here 1 upon root 1 plus 4x square. 1 upon root 1 plus 4x square. In the list of formula, we have 1 upon root x square plus a square. We are having formula for this result. So this can be converted in this form. So for that, what we do here, this is 2x square. It is 2x square. So putting this as dx upon square root of 2x square plus 1 square. And now in place of x, this is 2x. So what we do, we take 2x equal to t. So this form can be derived. 2x is t, so 2 dx is dt. So integral is, dx is, here 2x is t, 2x is t, 1 as it is, and x dx, dx is dt by 2. So dx is dt by 2. So here we keep dt by 2, we are putting outside. So it is equal to, now 1 upon root x square plus a square, its integral is log mod x plus root x square plus a square. So log mod t plus root t square plus 1 square plus c. And putting value of t is 2x. Here t is 2x, so 4x square plus 1 plus c. So this is required value. Now look here. If you observe this function, then you can find its matching with 1 upon root a square minus x square. 1 upon root a square minus x square. So here we need x square. So for that, 25x square we observe as 5x square. 25x square is 5x square, 9 is 3 square. Now you can see that we are getting this pattern. So to have this pattern, now we take substitute 5x equal to t. Take 5x equal to t. Taking 5x equal to t, 5 dx is dt. So dx is dt upon 5. So integral is dx is dt upon 5, put outside, root 3 square minus t square 1 by 5 now as it is, and application of this formula 1 upon root a square minus x square. What is this formula? Sine inverse x upon a plus c. So here sine inverse t upon 3 plus c. Putting value of t 1 upon 5, sine inverse value of a t is 5x by 3 plus c. In this question, observe numerator sec square x dx. Sec square x dx can be removed if we take tan x equal to t. So because here denominator is in terms of a tan x, taking tan x equal to t, derivative of tan x is sec square x into dx equal to dt. So integral is tan x is t, 4 we keep as 2 square, and sec square x dx is dt. So it is 1 upon root x square plus a square. 1 upon root x square plus a square, this formula. So it is log mod x plus root x square plus a square plus c. That is log mod, what is t? T is tan x, tan square x plus 4 plus c. This is required value. Now slight variation in method. See, whenever we want to integrate ax square 1 upon ax square plus bx plus c, or integral of 1 upon square root of ax square plus bx plus c, to obtain such type of integrals, if integrand is 1 upon quadratic polynomial, 1 upon square root of quadratic polynomial, then what will be the procedure? So remember, procedure is in ax square plus bx plus c, we will split up this constant in two parts, c1 and c2. This c will be split up in two parts such that this part becomes last term of a perfect square polynomial. This should be perfect square polynomial. And this number, it can be any positive or negative. This can be any positive or negative real. In this method, whenever numerator is 1, denominator is with or without radical sign, a quadratic polynomial given, then first term and middle term keep as it is. Split up a constant in two parts such that one part becomes last term of perfect square polynomial, and other part it can be any positive or negative real. and because then this will be perfect square polynomial, it will be then something like this: alpha x plus beta whole square. Because it will be perfect square, its simple form will be alpha plus x plus beta whole square equal to alpha x plus beta whole square. And then we will take substitute, then we will take help of substitute. Alpha x plus beta equal to t. Let us see procedure in this question. Here 1 upon, by this method, 9x square plus 6x, keep as it is. This plus 5 we are splitting in two parts, such that one part is last term of this perfect square polynomial and other part any real. It can be positive, it can be negative. And to find the last term of perfect square polynomial, middle term square upon 4 into first term. So middle term square 36x square, 36x square upon 4 into 9x square. So middle term square 36x square upon 4 into first term 9x square. So 36x square upon 36x square. So this will be plus 1. Sometimes if polynomial is easy, you can also calculate orally. So to make this perfect square polynomial, we have to put here plus 1. But we are given 5. We cannot change value. So to maintain value, keep here plus 4. So 5 is split up in two parts, 1 plus 4. So and here keep dx. So integral of, now this is 3x plus 1 whole square and 4 is 2 square. So say 3x plus 1 whole square. We will obtain such expression alpha x plus beta whole square after converting this in perfect square polynomial. And then we take alpha x plus beta equal to t. Now we use substitute. We are taking 3x plus 1 equal to t. 3x plus 1 is t. Differentiating this with respect to x, derivative of 3x plus 1 is 3 into dx is dt. So dx is dt by 3. So integral is 1 upon, this is t square plus 2 square, and dx is dt by 3. Put dt and by 3 put outside. And now this is 1 upon x square plus a square. So 1 upon x square plus a square, matching with that formula, 1 upon a, tan inverse x upon a. So its integral is 1 upon a, this is the 1 upon a tan inverse x upon a plus c. Now value of x, 3x plus 1. So that is 1 upon 6 tan inverse 3x plus 1 upon 2 plus c. So it is required integral. Now in this question, here integral of 1 upon square root of, similar procedure, whether quadratic polynomial is free from radical sign or if it is in radical sign. Procedure is same. So here this is constant, 7 is constant, and we will split up 7. But look, x square term is negative. If x square term is negative, then perfect square polynomial set in second place. This polynomial we will set in second place, and remaining constant that we will set in first place. If x square is negative, so this is negative, so keep here minus x square, put minus 6, x square and x term keep as it is. So here x square term was positive. If x square is positive, quadratic polynomial set in first place and remaining number in second place. If x square is negative, quadratic polynomial set in perfect square polynomial set in second place, and here we will put remaining constant at last, that is C2. So see, to make this perfect square polynomial, middle term square, see, keep one point in mind, x square is a negative, first term is negative, so here we have to put negative number with the last term. If x square is negative, last term always it should be negative, because this negative we will take a common, minus we will take common in the next step. So taking minus common, this will be then positive and last term should also be positive. So to make both positive, if x square is negative, set here negative. Now last term is middle term square upon 4 into first term. Middle term square 36x square upon 4 into first term. So 36x square upon 4x square. So 9. So this will be 9. Or because this is simple quadratic polynomial, to make it perfect square, you can also calculate orally, no need to apply formula, because it is simple, x square 6x, so last term should be 9. Simple way of calculating last term is, if you divide this by 2, so 3x is left, then 3 square is 9. So here minus 9 is taken, but we are given 7 and we are splitting 7 in two parts. That one part is last term of perfect square polynomial and other part is remaining number. So this should be 16. 16 minus 9 is 7. So dx. So it is equal to, this can be written as dx upon square root of 16 is 4 square minus, taking minus common, this will be x plus 3 whole square. Taking minus common, it will be x square plus 6x plus 9, so x plus 3 whole square. And now we take substitute, x plus 3 equal to t. So derivative of x plus 3 is 1 into dx is dt. So integral is dx is dt square root of 4 square minus t square. So 1 upon root a square minus x square. Formula 1 upon root a square minus x square. So sine inverse x upon a plus c. So sine inverse x upon a plus c, and its value of t is x plus 3. So putting here x plus 3, this is required integral. Now in this question, Here this is a product of two linear factors. If we expand this linear factors, product of linear factors, then it will be quadratic. X square minus 2x minus x minus 3x plus 2. So it is like this. Now again similar procedure. We are going to split up plus 2. So dx upon square root of x square minus 3x. If x square term is positive, perfect square polynomial set in first place, remaining number in second place. We are going to split up plus 2 in two parts, C1, C2. This will give perfect square polynomial. Now here we want last term. Last term will be positive because x square is positive. If x square is negative, last term keep negative. Now here last term is middle term square. Middle term square minus 3x into minus 3x upon 4 into first term. So what will be last term? 9 by 4. So we keep here 9 by 4. Now we want plus 2. Second part plus 2. Sum of these two numbers should be plus 2. So say 9 by 4 is C1. Second part is C2. 9 by 4 plus C2 is 2. So C2 is 2 minus 9 by 4. So C2 is 8 minus 9 minus 1 by 4. So we keep here minus 1 by 4. So this is rough work to calculate last term. So doing this procedure, now this can be expressed in this form. So it is equal to dx upon square root of x minus 3 by 2 whole square minus 1 by 2 whole square. Now it's a pattern of 1 upon x square minus a square, root x square minus a square. So to look that pattern, we take substitute. X minus 3 by 2 is t. Taking x minus 3 by 2 is t. So dx is dt. So integral is dx is dt root t square minus 1 by 2 square, and integral of 1 upon root x square minus a square is log mod x plus root x square minus a square plus c. 1 upon root x square minus a square, so log mod x plus root x square minus a square plus c. So this is log mod, value of t is x minus 3 by 2. Here x minus 3 by 2 whole square minus 1 by 4 plus c. And now we are putting its original form. T is x minus 3 by 2. 1 by 2 square is 1 by 4. Now see, its original value is, I keep here 1 by 2 whole square. Now see, what is its simple form? Its simple form is x square minus 3x plus 2. So I keep here now x square minus 3x plus 2. So it is equal to log mod x minus 3 by 2 plus root x square minus 3x plus 2 modulus plus c. So after this step, this is answer. Now see, again a new variety. If we want to obtain integral of ax plus b upon ax square plus bx plus c, numerator is a linear function, denominator is quadratic function, numerator is linear polynomial, quadratic is quadratic polynomial, or capital AX plus capital B upon root ax square plus bx plus c, to obtain integrals of such functions in which numerator is linear polynomial, denominator is quadratic polynomial with or without radical sign. Starting is, we shall find a and b, capital A and B, these are constants, by supposing ax plus b equal to m into d by dx of, sorry, here we shall find or we can say that in procedure is, we take ax plus b equal to m into d by dx of ax square plus bx plus c plus n. Whether quadratic polynomial is without radical sign or with radical sign, in either of the cases, take here ax square plus bx plus c. If here radical sign is given, don't put here radical sign. Radical sign is given or not given, but here you don't keep radical sign. So in either of the cases, we take this expression. After taking this expression, we will find m and n. So we shall find m and find the value of n. And this new expression replace ax plus b, that is numerator, by new expression. Let us understand in this example. Say here, its a pattern is ax plus b upon ax square plus bx plus c. So his starting is take 5x minus 2, take ax plus b equal to m into this number plus n. So m into d by dx of 1 plus 2x plus 3x square plus n. Now simplifying RHS, m into its derivative is 1, derivative of 1 is 0, derivative of 2x is 2 plus 6x plus n. That is, now here there is only one term with x. So m into 6x, so it is 6m into x. Then keep constants in second place. 2m plus n, 2m plus n, these are constants. So now we compare both the sides. Here coefficient of x is 5, it is equal to coefficient of x. This will be equal. and constant equal to constant. Minus 2, it will be value of 2m plus n. So comparing both sides, therefore coefficient of x on the right hand side 6m equal to coefficient of x on left hand side, and constant on the right hand side equal to constant on left hand side. Therefore m is 5 by 6. Putting m 5 by 6 here, 2 into 5 by 6 plus n equal to minus 2. So this is n equal to minus 2 minus 5 by 3. This is 5 by 3. So n is minus 6 minus 5 minus 11 by 3. This is n, this is m. So therefore 5x minus 2 equal to m is 5 by 6 into d by dx of 1 plus 2x plus 3x square plus n is minus 11 by 3. Now instead of this expression we can put 2 plus 6x. So I am putting here 2 plus 6x. Instead of this part I am putting 2 plus 6x. This is 5x minus 2. 5x minus 2 equal to m into 2 plus 6x plus n. We say this is 1. So putting in 1, from 1, 5x minus 2 equal to 5 by 6 into 2 plus 6x. It is 2 plus 6x plus n is minus 11 by 3. Minus 11 by 3. So this is the value of numerator. Value of numerator. Now we replace value of numerator by new expression. So this is new expression. So integral is, therefore integral is 5x minus 2 I replace by 5 by 6 2 plus 6x plus minus 11 by 3 upon 1 plus 2x plus 3x square dx. Now dividing this individually, this number dividing by polynomial 5 by 6 into 2 plus 6x upon 1 plus 2x plus 3x square dx. This number upon this number dx plus minus 11 by 3. So minus 11 by 3 dx upon 1 plus 2x plus 3x square. Now see, this part we are saying I1. This is I1 minus 11 by 3 I2. This is I2. We say equation 2. This is I1, this is I2. Now I1 is 2 plus 6x upon 1 plus 2x plus 3x square dx. Now look, In this method, MN method, whatever will be the first term of a new expression, from that first term it will be nothing but derivative of a denominator. So taking this as t, take t, 1 plus 2x plus 3x square equal to t. Its derivative is 2 plus 6x into dx equal to dt. So integral is I1 is, see this was t, so it is t. So 2 plus 6x dx is dt. So it is log of modulus t plus c1. Integral of 1 upon t is log mod t. Now value of t is 1 plus 2x plus 3x square plus c1. This is I1, value of I1. So this part is calculated. Now this part, and I2 is dx upon 1 plus 2x plus 3x square. Now say here numerator is 1. Numerator is 1 dx. Denominator is quadratic equation, quadratic polynomial. So method of previous examples, whenever numerator is 1, denominator is a quadratic polynomial, we split up 1 in such a way that one part becomes last term of perfect square polynomial, other part any real number. This is positive, so keep this, we are setting a perfect square polynomial in first place. So 3x square plus 2x keep as it is, and here this 1 we are splitting in two parts. Here split up 1 in two parts. First part will be last term of perfect square polynomial, other part can be any real number. Split up 1 in two parts. This will be last term of perfect square polynomial, this will be remaining number. So see, this is first term, this is middle term. So last term is middle term square upon 4 into first term. So this is 1 upon 3. 4x square will be cancelled. So last term will be 1 upon 3. This is 1 upon 3, but we want total 1. So in 1 upon 3, if you add 2 upon 3, then total will be 1. Second number can be positive, it can be negative. So this becomes dx upon, now this is root 3 into x plus 1 upon root 3 whole square plus root 2 upon root 3 whole square. Root 3x plus 1 upon root 3 whole square plus root 2 by root 3 whole square. Now this part we are taking t, substitute. So we are taking root 3x plus 1 by root 3 equal to t. Taking this as t, we have its derivative root 3 into 1. So this is derivative of LHS. So root 3 into dx is dt. So dx is dt by root 3. So therefore I2 is integral of dx is dt by root 3. This was t upon t square plus root 2 by root 3 square. So it is 1 upon x square plus a square. So its integral is, it is equal to 1 upon root 3, keep as it is. Now 1 upon x square plus a square. So by formula 1 upon a tan inverse x upon a plus c2. C2 is arbitrary constant. So 1 upon x square plus a square, 1 upon a tan inverse x upon a plus c2. So this is then 1 upon root 2 tan inverse root 3 into t. What is t? This is t. So root 3 by root 2 into t. T is root 3x plus 1 by root 3 plus c2. Tan inverse root 3 upon root 2 into t plus c2. So that is, it is equal to 1 by root 2 tan inverse root 3 into root 3 is 3x by root 2 plus 1 by root 2. So that is 3x plus 1 by root 2 plus c2. So this is value of I2. Let me say this value equation 4, this value equation 3. So putting values of I1 from 3, value of I2 from 4 in equation 2. So therefore putting values from 3 and 4 in 2. So integral is 5 by 6 times I1. I1 is log mod 1 plus 2x plus 3x square plus c1 minus 11 by 3 times I2. I2 is, here now I keep I2. I2 is 1 by root 2 tan inverse 3x plus 1 by root 2 plus c2. So this is equal to 5 by 6 times log mod 1 plus 2x plus 3x square, 5 by 6 into this number, minus 11 by 3 into this number. So 11 by 3 root 2 tan inverse 3x plus 1 by root 2, then plus 5 by 6 c1 minus 11 by 3 C2, it is equal to C, arbitrary constant C, where C is 5 by 6 C1, 5 by 6 C1 minus 11 by 3 C2. Integral of 6x plus 7 upon square root of x minus 5 into x minus 4. Say this is a quadratic polynomial. First of all, let me show in quadratic form. 6x plus 7 upon square root of, it is x square minus 9x plus 20. Now procedure, exactly ditto procedure which we perform in last question. So here numerator is a linear polynomial, capital AX plus B. Denominator is a quadratic polynomial with a radical sign. So what we do, let numerator express as m into d by dx of a denominator. Denominator is with a radical sign, but don't keep your radical sign. Keep without radical sign, plus n. So if here radical sign is given or not given, in every case this should be free from radical sign. So that is 6x plus 7 equal to m into, now its derivative is 2x minus 9 plus n. Let me say this is equation 1. Now we find value of m and n. So it is 2m into x minus 9m plus n. Now see, we compare coefficients. 6, it should be equal to value of 2m. 6 is 2m. So comparing both sides, 2m is 6 and 7 plus 7, it should be value of this constant part. So minus 9m plus n equal to 7. So m is 3. M is 3. So putting m3 here, minus 9 into 3 plus n is 7. So n is 27 plus 7, 34. Therefore, putting value in 1, given numerator is m, this is 1. Given numerator, putting value in 1, given numerator is equal to m is 3 into 2x minus 9 plus n is 34. So now we replace this 6x plus 7 by this expression. Therefore integral is 6x plus 7 is 3 into 2x minus 9 plus 34 upon square root of x square minus 9x plus 20 into dx. So numerator is replaced by new expression. Then next step, divide individually. Dividing first number, 3 take out, 2x minus 9 upon square root of x square minus 9x plus 20 dx plus 34 into 1 dx upon square root of x square minus 9x plus 20. Now let me call this part is I1 and this part is I2. So it is equal to 3I1 plus 34I2. Suppose this is 2. Where I1 is 2x minus 9 upon root x square minus 9x plus 20. So in this method, after dividing numerator by denominator, in first term, numerator will be always derivative of this quadratic polynomial. So taking this as t, this can be removed. So we take x square minus 9x plus 20 equal to t. Therefore, 2x minus 9, its derivative is 2x minus 9, dx is dt. So this will be dt. So I1 is dt upon root t. It is t raised to minus half. T raised to minus half. That is, its integral is t raised to minus half plus 1 upon minus half plus 1. That is t raised to half upon half plus c1. So this is 2 root t plus c1. So it is equal to, so I1 is 2 root t. What is t? X square minus 9x plus 20 plus c1. This is result 3. So calculation of I1. Now coming on I2. And I2 is I2 is 1 upon square root of x square minus 9x plus 20. Now here numerator is 1 and this is quadratic. So that method, splitting 20 in 2 parts such that one part is last term of perfect square polynomial plus something and something. Going to split up 20 in 2 parts. Now here last term is middle term square 81x square upon 4x square. So x square cancel, this will be 81 upon 4. We need plus 20. So 81 upon 4 plus something is 20. So something is 20 minus 81 by 4. So something is minus 1 by 4. So this will be minus 1 by 4, or you can calculate also it orally. It's simple. We want plus 20. To have plus 20, total should be 80 by 4. Here already you have taken 81 by 4. So to have 80 by 4, subtract 1 by 4. So simple. No need to do such rough work. So many times in such kind of easy numbers you can do directly without doing any rough work. So it is equal to, this is equal to integral of dx upon square root of, now this is x minus 9 by 2 whole square minus 1 by 2 whole square. Now this part we take t, we are taking x minus 9 by 2 is t its derivative is 1, so 1 into dx is dt. So integral is dx is dt square root of t square minus 1 by 2 square. So 1 upon root x square minus a square. 1 upon root x square minus a square. So log mod x plus root x square minus a square plus c. Here we take c2. Putting value of t, log mod t is x minus 9 by 2 plus square root of t square is x minus 9 by 2 whole square minus 1 by 4 plus c2. This is equal to log mod x minus 9 by 2 plus, now see, simple form of this expression, you can see that its simple form is x square minus 9x plus 20. So square root of x square minus 9x plus 20 plus c2. This is 4. So from 3 and 4, putting values, from 3 and 4, we are putting in equation 2. We have integral equal to 3 times I1. So 3 times, what is I1? I1 is 2 root x square minus 9x plus 20 plus c1. So this is I1. 3 times I1 plus 34 times I2. This is I2. Log mod x minus 9 by 2 plus root x square minus 9x plus 20 plus c2. So it is equal to 3 into 2, 6 root x square minus 9x plus 20 plus 34 into log mod x minus 9 by 2 plus root x square minus 9x plus 20, x square minus 9x plus 20 modulus. So here it was modulus of this number. So 34 times log of modulus of this number plus c. This c is 3 times c1 plus 34 times c2. So c is arbitrary constant. X plus 2 upon square root of 4x minus x square. Say this is quadratic. Numerator is linear. So whenever a numerator is linear, denominator is a quadratic polynomial with or without radical sign. We take x plus 2 equal to m into d by dx of 4x minus x square plus n. M into d by dx of a denominator plus n. So x plus 2 equal to m into 4 minus 2x plus n. Let me say this is equation 1. Now to find value of m and n, expanding right hand side, 4m minus 2mx plus n. So that is equal to minus 2mx keep as first term, constants in second place, 4m plus n. This is second place constant, this is coefficient of x. Now comparing both sides, here coefficient of x is 1, so 1 equal to minus 2m and plus 2 equal to 4m plus n. Therefore minus 2m is 1 and 4m plus n is equal to 2. Therefore m is minus 1 by 2. M is minus 1 by 2. So putting here minus 1 by 2, 4 into minus 1 by 2 plus n is 2. So this is minus 2 plus n is 2. So n equal to 4. So from 1, x plus 2 equal to m is minus 1 by 2 into 4 minus 2x plus m is 4. So this is expression for x plus 2. So using this new expression in a numerator, so integral is, therefore integral is, now given a numerator we replace by new expression, minus 1 by 2, 4 minus 2x plus 4 upon square root of 4x minus x square. Now dividing individually, this is equal to minus 1 by 2 times 4 minus 2x upon square root of 4x minus x square dx plus 4 into dx upon root 4x minus x square. Now as we did in last questions, this part we are taking I1, this part we are taking I2. So minus 1 by 2 times I1 plus 4 times I2, suppose this is result 2, where I1 equal to integral of 4 minus 2x in upon root 4x minus x square. And look, in this procedure in I1, this will be always derivative of this part. So we take this part as substitute t, 4x minus x square is t. Therefore its derivative is 4 minus 2x, dx is dt. So this will be dt. So integral is I1 is dt upon root t, that is it is t raised to minus half dt. So t raised to half upon half plus c1, that is it is 2 root t plus c1, and value of t is, it is equal to t is 4x minus x square plus c1. So this is I1, we say this is result 3. Now I2 is, and I2 is, this was I2, dx by root 4x minus x square. Now look, numerator is 1, numerator is 1, in denominator a quadratic. In this quadratic, x square term is negative, and when x square is negative, perfect square polynomial set in second place, and adjusting remaining number keep in first place. X square is negative, first of all put x square, then put plus 4x. Now to complete this perfect square polynomial, this should be minus 4, but here constant is 0. Because here constant is 0, to maintain 0, because we have taken here minus 4, so I am taking here plus 4. So it becomes dx upon square root of, this is now 2 square minus, and this is now x minus 2 whole square. And now we take x minus 2 is t, this is t, so dx is dt, so I2 is dx is dt root 2 square minus t square. So it is 1 upon root a square minus x square formula. So that is sine inverse t by 2 plus c. C means here c2. C2 is arbitrary constant. So sine inverse, now t is x minus 2 by 2 plus c2, so this is 4. Now 3 and 4 we keep in result 2. So putting values from 3 and 4 in equation 2. I is equal to minus 1 by 2 times, this is I1, plus 4 into I2, plus 4 into I2 is sine inverse x minus 2 by 2 plus c2. So this is equal to minus 1 by 2 is minus root 4x minus x square plus 4 times sine inverse x minus 2 by 2, and joining constants plus c, where c is minus 1 by 2 c1 plus 4 c2, constant plus constant is constant, so this is value of I. X plus 2 upon root x square minus 1. So here a running method is, this is a quadratic polynomial, this is linear polynomial, so let x plus 2 is equal to m into d by dx of x square minus 1 plus n. So beginning by this method, now you can finish it, you can do, but sometimes without taking help of m and n, you can do directly. Say here, sometimes no need to use this expression, it can be, you can determine from observation. See, this is very simple. Now see, what is its derivative? Derivative of x square minus 1 is 2x. It is 2x, and here x is given. So what we do? Here first of all I divide individually. Dividing individually, this is 2dx upon root x square minus 1. Dividing individually, next step is we take this number as I1, this number as I2. This is I1 2 times I2, where I1 is x upon root x square minus 1 dx. Taking here x square minus 1 equal to t. 2x dx is dt. So dx x dx is dt by 2. So I1 is x dx dt by 2. This is x square minus 1. So 1 upon 2, its integral is log mod x plus root x square minus 1 dt, sorry, here dt by 2, and this is t. X square minus 1 is t. So putting here t, x dx is dt by 2. So this is 1 by 2 t raised to minus half dt. That is 1 by 2 t raised to 1 by 2 upon 1 by 2 plus c. So it is root t plus c. We take here c1. T is root x square minus 1. So say this is 1. I2 is I2 dx upon root x square minus 1. Now see, this is simple. Log mod x plus root x square minus 1 plus c2. So this is 2. So from 1 into integral I is, putting here I1 was root x square minus 1 plus c1 plus 2 times I2 is log mod x plus root x square minus 1 plus c2. This is I2. So it is equal to root x square minus 1 plus 2 times log mod x plus root x square minus 1 plus c, where c is c1 plus 2c2. So it is required integral. So see, every time no need to take help of MN procedure. Without taking help of MN, sometimes directly this can be started.